I'm going to work through parts of the problems of lesson 9.1.1. As you're going through, please make sure you're pausing this so you can actually work out some of the problems on your own as well. So first of all, starting with problem 1, this is not new material. We're doing zero product property, which is what we actually learned in chapter 8. So the first thing we need to do is on problem A, this is not currently set up to use zero product property. So think about what you need to do. Pause it right now if you need to, and then go through and figure out your first step, and I will give you then a hint after that. Okay, hopefully you've figured out that you need to get this equal to 0 in order to do your zero product property. So the first thing I need to do is subtract the 9 from both sides, giving you 0 equals 3x squared plus 4x minus 15. Now that needs to be factored in zero product property. So again, pause it and figure out your answer. Okay, hopefully you've done that. So I'm going to set up my generic rectangle. 3x squared, a negative 15. My diamond problem has a negative 45x squared on the top, and my middle term goes on the bottom of 4x. That means the sides of my diamond problem are positive 9x and negative 5x. Those go in the open spots here. Looking at greatest common factors from these two, and x is my greatest common factor. X times 3x gives me 3x squared. X times negative 5 gives me negative 5x, and 3x times 3 will give me 9x. So now this factors into 0 equals x plus 3 times 3x minus 5. Zero product property now means I take each one of these factors, x plus 3, and set it equal to 0. And now I'm going to solve both of those problems, because if I find the value of x that makes this equal to 0, that's this factor. Does not matter what's in the other factor, they'll equal 0. And same with the 3x minus 5. If I figure out what a value of x makes this equal 0, it doesn't matter what number that is, the product will equal 0. So for the top one, I get x equals a negative 3. For the bottom one, I'm going to add 5. And 3x equals 5, so then x will equal 5/3. And those are the two solutions for problem A. Problem B is already factored for you, so go ahead and do that one. And problem C, you need to factor it first. Make sure you realize that on that one you can do a greatest common factor. So go ahead and pause it and work on those. Okay, for problem B, that's one factor and that's one factor. I'm not going to go through and show all the work. You get x equals 5 and negative 3 over 2. If you're not sure on how I got that, please let me know. Send me an email. Problem C, your greatest common factor for this problem is x. So you can take that out. It's x plus 6. That factors into x times x plus 6. So zero product property gives me 0 and negative 6. Problem 2. They said if you graph this, it's going to be this graph that's given here. How can we use that graph to verify our solution to this problem? So we want to know, when does this graph here equal 9? So if we put a line here at 9, so there was 10 right up there, so it's just below that. We have our solution right there, and our solution right there. If you recall in the last problem, the solution was negative 3. The other one is a decimal, so it was a fraction when we solved for it. And now we have our answer right here. That one was 5/3, if you recall. So our two solutions are negative 3 and 5/3 from that. If we wanted to look at a table for problem B, well, we want to look at the y value of the table when it equals 9. We're going to have one at -3. The other one might be hard because our x value, again, was a fraction of 5/3. You may not really see it in a table. So not really maybe the best way to use a table. And then a graphing calculator, you can go through and take a look at those as well from your graphing calculator. Problem 3, we're taking a look now at a different one. And if you read through the problem, Kira said that we will not be able to go through and factor that. So remember that if a diamond problem works out, we can factor it. The diamond problem would be a -1x squared, and the bottom would be a -6x. Nothing works there, so Kira is correct. It is not factorable. So if you go through and graph it, we are going to have x-intercepts though. So you can use a graphing calculator, you can check it on a graph, you can look it up on Desmos if you would like. So here's what we're going to do. I'm going to do completing the square, is what we did in lesson 8.2.5. I'm going to do it a little bit differently than what they showed here with the algebra tiles. I'm going to be building it by hand. I'm going to switch the screen over here. So I have 0 equals x squared minus 6x minus 1. So again, if I want to figure out x-intercepts, I'm going to take this x squared minus 6x minus 1, and it's going to be equal to 0. And I'm going to complete the square. If you remember the first thing I do with completing the square, or maybe you need to go back and look at that video, I'm going to take my constant term and just move it over to the side. I'm going to build a square with this. So I have my x squared. I have -6x's. So with -6x's, if I'm building a square, I need to have the same number on each side. So I have -3 of them on each side. That means that I have an x squared here. I have -3x's, -3x's. So this part of my equation is now taken care of. That gives me a side length of x and 1 and 1 and 1. So it's an x plus 3. And same thing here, x plus 3. Now what I'm going to do is I need to complete that square, because if you look at it, this is not a square. I need to finish off that part. Well, that is going to be 3 times 3, so I'm adding 9 to complete the square, and you can see how I've added it into my equation. But now my equation is no longer balanced. So the stuff in green equaled 0, but I've added this here. So in order to balance this out, if I added 9, I need to subtract away 9. These two make a 0, and now the stuff in green all works out. This set of parentheses right here, that is my square right here. You can see all the elements in there, my x squared, my -6x's, and my 9. Those are all part of that. That is creating now an x minus 3 square. If I simplify what's on the outside, that is a -10, and that now equals 0. So now what I've done is I've gone through and I've completed the square, which is what they wanted me to do in these couple of steps here. So now I want to solve for this. In part D, they want me to solve. So if I need to solve this equation, the first thing I want to do is add 10 to both sides. I now have 10 equals x minus 3 squared. To solve this problem, I'm going to take the square root of both sides. Now something happens here. When I square root the 10, I actually get two solutions. I get both positive and negative square root of 10. And that is because when I have this original problem, some number squared equals 10, that number could be both positive or negative, and when I square it, I will get a positive 10. So when I'm working backwards and square rooting, I will get both positive and negative of that solution. So if I use my calculator and approximate the square root of 10, that gives me approximately 3.162. The square root of x minus 3 squared is just going to be x minus 3. I now will set up two separate problems, one for the positive and one for the negative. So I'm going to go to a new screen. So my problem here was this. So now I will have x minus 3 equals the positive 3.162. And my other option will be x minus 3 equals the negative 3.162. Both problems are going to be solved the same way. I'm going to add 3. So I get x equals 6.162. And with the purple problem, I will get x to equal a negative 0.162. So then the next part here, those are irrational numbers. And the reason why they're irrational numbers is because when I take the square root of 10 in this step, I get decimals that do not repeat, and they never stop. The decimal goes on forever. So that's called an irrational number. I'm also going to approximate it, and that's what we did with the 3.162. So the exact form would have been the square root of 10. The approximation was about 3.162. So now you can test out that problem right there and see what you can come up with doing the same steps. Your homework is also going to involve that. Best of luck.